Greetings. Welcome to my video on doing examples for the chi-square test of independence. Here's my second example. We're looking at number 14 from the worksheet. The Boeing Commercial Airline Group conducted a survey of 133 planes, either being flown or on order from 3 airline companies based in 3 different countries. The sample data is summarized in the following table. So you have the contingency table here, where you're going to need to produce the sums. Is there sufficient evidence to support the claim that the distribution of planes flying and planes ordered is independent of the airline companies? So this is an obvious question that's always asked, and clearly you see we are testing independence. So I'll start with my null and alternative here. My null hypothesis will be the independent statement. So independence or independent and dependence. All right, so there's my first step. First step always easiest to do. My second step, as we all know, is the chi-square value, the test statistics. For that, we'll go to our Excel sheet to do it. You've already seen me do it. So I've transferred the problem for you here. So I have the contingency table you see here. I've written the table. I figured out all the row sums and column sums and the grand total, which is 133. So let's try to do this. I've written the O's here. The sum is 133. And hopefully when I'm done calculating all the expected frequencies and sum them all, I'll end up with 133. So I'll start with the first one for 36. Again, the row total of 36, which is 72, multiplied by the column total of 36, which is 52, divided by the grand total, which is 133. For 22, it will be row total times column total divided by grand total. Now you see this is one time, and I did mention it maybe on a previous video, you can't just drag this down, unfortunately, because you have to actually write a little sort of programming code here to, if you wanted to drag it down. This one you're just gonna have to do it one by one. It's all right, much better than doing it with a calculator, piece by piece, paper and pencil. So you're still, top 10% of easiness here. So anyways, so let's do it for 14. What is it? So 14 row total is 72, multiplied by the column total, which is 36, divided by the grand total. And then for 16, row total times column total divided by grand total, which is 133, right? For 23, row total, 61 times column total for 23, 45, divide by the grand total. It's easy to make a mistake here, guys, so you gotta be very careful. Your eyes could play tricks on you, so be very careful with this. And of course, you could always check at the end if the sums are not the same. That means you made an error somewhere, you clicked on the wrong thing. And usually that's what the problem is. So for 22, again, it will be the row total, which is 61, multiplied by the column total, which is 36, divided by the grand total, which is 133. And again here, let's hope we haven't made a arithmetic error. Oh, we haven't. We're good. We're safe. So now, let me calculate the test statistics here now. Now this one you can drag down. So O, we'll just do it once, minus E, quantity squared divided by E. And this now you can, oops, sorry. This one you can fill down, and if I sum them up, so I have a test statistics of 8.642. So I can just copy that here, 8.642. So that's my test statistics for this exercise. And now that we're here, I may as well calculate the critical value for the rejection region, so I can just run to the other page with both pieces of information, which is steps 2, which is this, and step 3, which is, well, we all know it's going to be a right tail chi-square distribution. So chi-square inverse right tail probability is 0.01. And degrees of freedom is, here is 3 columns, so 3 minus 1 is 2, and 2 rows, so 2 minus 1 is 1, so 2 times 1 is 2, so degrees of freedom is 2. Again, 3 minus 1 times 2 minus 1. 3 minus 1 times 2 minus 1. Because if I draw it, see, you get 3 minus 1. Well, I can't draw it when I'm in the middle of a command, I guess. So it's just 3 minus 1 times 2 minus 1, which is 2. And there is your critical value, which is 9.210. Okay, so let's move on to my notability page, and done all the calculations. Now I can just finish the write-up. And don't forget, you're not just going to give me a bunch of numbers as the answer. You have to actually do the write-up. And a lot of you guys may be just wanting to send me a couple of numbers, and that not going to be accepted. You need to do these problems exactly the way you watch me do it on my videos. Alright, so my test statistics is 8.642. 8.642, and for this one I'll go with 3 decimal places. Doesn't really matter. My rejection region is going to be a right tail chi-square distribution. Here's my right tail chi-square distribution. And there's my rejection region, always on the right tail with alpha significance level. And we already did that. On the next page, we had alpha 0.01 with the degrees of freedom of, and I'll do it here, 3 minus 1 times 2 minus 1. 3 minus 1 is 2, 2 minus 1 is 1, 2 times 1 is 2. So you'd use an alpha value of 0.01 and the degrees of freedom of 2 units. And now I showed you the value on the Excel page, so it's 9.210. And there's my critical value. And now you clearly see that, and that's 0 here. So you clearly see that my test statistics falls in outside the rejection region. So my decision here will be fail to reject the null hypotheses, which concludes independence. Which means flying on ordered are independent of which company you ordered it from. At least that's what statistics tells us. Thank you.